How are submarines built? In this video, we look at how these complex and fascinating marvels of a vehicle are put together. Now, it all starts at a concept stage, when all the key specifications of the sub are chalked out. Say, the purpose of the sub. Are you building a nuclear attack sub like the US Nautilus? Or a small research submersible diving to explore new aquatic wonders? Then there's of course the big size question. Are we talking massive multi-purpose subs like the Russian Typhoon, the biggest ever built, or a Japanese midget sub like the one that orchestrated the attack on Pearl Harbor? Ultimately, it is diverse factors such as operating depth, endurance, speed, and armament weaved together in the complex equation of building a new sub. Once these initial specifications are approved, detailed engineering plans are developed for the hull structure, propulsion systems, power plants, ballistic tanks, sonar suites, and other features and subsystems. But of course, let's start with the main body of a submarine, the hull, which is typically made of high-strength steel or titanium. Most modern subs have two hulls. The inner hull protects the crew and equipment from the bone-crushing water pressure of the ocean, or for that matter, the freezing temperatures, while the other hull is what gives the sub its shape. To make the hull, steel plates are cut with acetylene torches that are then molded into the desired hull shape using industrial-grade rollers. These plates are then placed around a wooden template that outlines the shape of the hull before they are welded together. The same is done for the outer hull, but space left between the two hulls for ballast tanks, which are crucial for controlling a sub's ability to sink or rise in the water. Back during the Cold War days, the act of diving and surfacing was only possible using air and water pumps, until of course this guy here, Nathaniel Simons, discovered the use of mechanically operated tanks that work their magic between the hulls. By flooding the tanks with water, the sub becomes heavier and sinks, and if the sub wants to surface, you simply pump out the water from the tanks and float upwards. A protective coating is applied to the interior and exterior surfaces of the tanks to prevent corrosion and securely attach them to the hull. The tanks are then connected to the control systems like the valves, pumps, and piping needed for them to work. Once this outer shell is made, it's time to set up the interior with all the equipment, machinery, and systems connected into one integrated machine. The propulsion system is where the sub gets its power, from nuclear reactors in case of nuclear subs to electric motors in case of diesel-electric ones. The engine propellers are carefully designed based on factors like intended use and range. Mechanical and electrical connections are then set up to transmit power from the engine to other components of the submarine, say the torpedo room or the sonar dome located at the front. A sub also carries special facilities like air purification units, water desalination systems, and waste treatment systems, as well as navigation systems like gyroscopes and GPS devices to help the sub navigate in the deep or track enemy vessels before they track them. This ping sound emitter sonar suite is usually located in the bow section or the nose, connected to power and data networks as they guide the sub underwater. To make the space livable, things like snorkels, refrigerators, ovens, ACs, and furniture are added at the end. But before this new sub is ready to make it to the open seas, there's months of rigorous testing and trials to ensure performance and safety. Dedicated teams testing for leaks, propulsion power, navigation accuracy, and communication networks to identify any flaw or potential source of accident, explosion, or fire. From $100,000 to a whopping $3 billion a piece for a nuclear sub, it takes a vast amount of money, time, and high-tech resources to build a new submarine. Gotta say, techniques of traveling underwater have come a long way, from little wooden spheres to the high-strength steel giants commissioned by navies today. As traditional periscopes are replaced by high-tech photonic sensors, as blade-powered propulsion is taken over by nuclear reactors fueled by uranium, it's fascinating to learn how subs have developed in the past 50 years. Remember, idea of traveling underwater is not a new one. It has been around since the time of Alexander the Great, believed to have ventured below the waters of the Aegean Sea in a glass barrel in 333 BC. But outside the world of Greek legends, it wasn't until the 1600s a man named Cornelius van Drebbel built the first recorded submarine, carrying the King of England with the help of oars to move and leather gaskets to stop the water from pushing its way in. But thanks to 200 years of advances in science and tech, coupled with a more rich understanding of hydrodynamics, modern subs are simply phenomenal machines. If you enjoyed learning about the ins and outs of building a submarine with us, you'll simply love our video on what life is really like if you were, well, actually inside one. Now, before dive your way out of this one, make sure you support our channel as try to make more fascinating content about ships, subs, and all things underwater.